Hello, welcome to ANS Solver. This is the seventh question of the paper. So as you can see, this is a curve equation of a curve which they have given to us. Okay, so we need to find an expression for dy by dx, and we need to show that the gradient at the point -1 comma 2 is -5 over 2. So as you can see here, we use something called as implicit differentiation. Correct, because as the easiest way to identify this is that two different letters x and y are used. Correct. Now we start with the differentiation. So the differentiation for x square, okay, the differentiation I know for x square, what I'll do is I'll split this into parts so that it's easier to solve. The differentiation for x square is simply 2x. Correct. Easy. Now the differentiation of 4xy. So we use product rule here, correct? Because 4x an entity is multiplied with another entity. So u is equal to 4x, v is equal to y. So now u dash, which is the differentiation of 4x, is 4, and v dash, the differentiation of y, is 1. But whenever we differentiate y, we multiply it by dy by dx. Correct? That's the rule of concept of implicit differentiation. So now my formula is simply uv dash minus vu dash. Okay, so we can simply write this as 4x dy by dx minus vu dash, which is 4y. Got it? So now what we can simply do is, vu dash plus uv dash plus vu dash, not minus, my bad, in the formula. Yeah. Okay, now the differentiation of 2y square will be 4y, but I told you whenever we differentiate y, we multiply it with a dy by dx, and the differentiation of 1 is 0. So now I can simply write this as 2x minus 4x dy by dx plus 4y, okay, minus 4y dy by dx equals to 0. Got it? So now I can simply write this as 2x minus 4x dy by dx, okay, plus 4y, minus 4y, okay, minus 4y dy by dx. Now I can keep all the dy by dx to one side, and I can write this as 2x minus 4y equals to 4x dy by dx plus 4y dy by dx. Now what I can simply do is I can write this as 2x minus 4y, okay, is equal to, I can take dy by dx common here, okay, and write this as 4x plus 4y, okay, and now I can write this as dy by dx equals to 2x minus 4y over 4x plus 4y. Okay, so this is basically the expression I have for dy by dx. Now we need to show the gradient, which is basically the dy by dx when the point is -1 comma 2. So -1 comma 2 basically means my x is -1, okay, and my y is 2. Correct, because the coordinates are x comma y. So I can simply, in the equation, I can substitute this, okay, 4 into, in the place of x there's -1 plus 4 into 2. So I get my dy by dx finally as -2 minus 8, which is basically -10 over -4 plus 8, which is -4 plus 8 is 4. So I can cut this by 5, I can cut this by 2 to get -5 by 2, which is what I needed to prove here. which is basically the final answer for part 1. Now, show that the curve has no stationary points. Okay, no stationary points basically mean when we equate the dy by dx to 0, okay, we should get no x coordinate, correct? If we get no x coordinate, that means there's no stationary point. That means that no x coordinate, the dy by dx is 0, correct? Now I have my dy by dx, which I can write from part 1, okay, simply as 2x minus 4y over 4x plus 4y. Okay, this is basically my dy by dx. Agreed? Now, when will my dy by dx be 0? My dy by dx will be 0 when my numerator will be equal to 0, correct? Whenever the numerator is 0, the whole thing will be 0. So we can equate 2x minus 4y to 0. Now what I can do is I can write this as 2x equals to 4y. Got it? Where I can get my x basically as 4y by 2. So I get my x, or what I can simply do is, because I need my x in the equation, I can write this as 2x by 4 equals to y. So I get my y as half x. Because I need the x coordinate so that I can show that there's no x coordinate. That's why I wrote everything in terms of y. Now I have my equation with me, which is x square minus 4xy. X square minus 4xy. Okay. Minus 2y square is equal to 1. Now in the place of y, I can simply put half x. So I can have this as x square minus 4x into half x minus 2 into half x the whole square equals to 1. So I can simply write this as x square. Your 2 1s are 2 2s are to get minus x square here. Okay. Here I can simply cut. I know this will become minus 2x square over 4 is equal to 1. So this is 2 1s are 2 2s are. So I can write this as x square. Sorry, this is actually 2x square here. Sorry. Okay. So minus 2x square minus x square by 2 equals to 1. So now I can simply solve this on the calci. I can do 1 minus 2 minus half. When I solve this, I get minus 3 by 2 x square equals to 1, which I can write as x square equals to minus 2 by 3. Now see, when I solve this, and x equals to the square root, okay, of minus 2 by 3 is not possible, correct? A square root of a negative is not possible. That means whenever my dy by dx is equal to 0, I don't get an x coordinate. That means I can just simply state that there's no stationary point. Okay, because I have no x coordinate when my dy by dx is equal to 0. Okay, so this is a very important concept you need to know. Now, find the x coordinate of each of the points on the curve at which the tangent is parallel to the y-axis. Okay, the tangent is parallel to the y-axis. So now, whenever, I'll just write my dy by dx again for the reference. So my dy by dx basically has 2x minus 4y over 4x plus 4y, if I'm not wrong. Let me just confirm it. Yeah. Whenever we need to find the x coordinate when the tangent is parallel to the y-axis, whenever y-axis comes, you need to know a thumb rule. We need to equate a denominator to 0. This is a thumb rule you need to know. So I can write this as 4x plus 4y equals to 0. Got it? So now what I can simply do is I can write this as 4x equals to minus 4y. Got it? So I need the x coordinate again. I need x. So I can write the equation in terms of y to get 4x over minus 4. Okay, so I get my y equals to minus x. Now I have the equation of the curve again, x square minus 4xy. Writing it for the reference again. Minus 2y square. Okay, minus 2y square equals to 1. So now I can simply equate minus x, okay, in the place of y. So I can write this as x square minus 4x into minus x minus 2 into minus x, the whole square equals to minus 1. So I can write this as x square. Now simply I can get plus 4x square here, okay, minus 2x square equals to 1. So here I simply get 5x square minus 2x square, which gives me 3x square equals to 1, which basically gives me my x square as 1 over 3, which can give me my x basically as, the plus or minus, because it's the square root of 1 over root 3. Okay, because whenever square root comes, there's a plus minus. Okay, so this is basically your x coordinate, okay, of each of the points on the curve. Okay,